Anything left over from those? You guys doing all right with the homework assignment on that? Yes?
Can we do the last one?
From the homework?
Yeah. We'll see. Or like something smooth.
So where did I put you? Rawr. Oh, okay, let me do one like that. Anything freaky? Not really. Okay. I'll make it even grosser than that. That's much grosser. So, to me, well, I'll show you by the book way to do it, and then I'll try to show you the way I do it. So you definitely want to start with this guy. You got the log of something divided by something. How can I rewrite that? That'd be the log of
A to the third power
minus log base c of 4bm squared. Because when I divide things, I subtract the powers. Now here's where people mess up. What can I do with this next? What is this? This is multiplication. That was division. That's minus. So I can break those up now with a cubed. Yeah, that log plus the other log. Don't get over there. Now here's where people mess up. The minus is in front of this. So anything that this is has to have a minus in front of it.
So that's a cube next to the log, the first log.
Yeah, that's a log c a cubed plus log c d5. Right? So you can break up products. You add the powers when you have something multiplying. Same thing I do here, right? So now how many things are on the inside? There's 4, there's b, and there's m squared. So I can do the same thing, log c4 plus log cb plus log cm squared. And you see what's going to happen with that negative? Distribute. I like it. Because what's on the bottom? All of these. So all of them should have a minus. And that's really the way I do this. I would go straight to this. I'd say log c a cubed plus log c d5 minus log c4 minus log cb. Because all this shit's on the bottom. It's all going to have a minus. The logs of the stuff on the bottom are going to have to be negative. It's a negative power, that's why they're on the bottom. They were flipped. If you do it this way, you will eventually get there if you remember. Right? So, at the very end, any term that's negative must have come from something that was on the bottom. Why does that make sense? Logs are powers, negative powers mean flip. There, see, it all comes back together. It's crazy. And now I can take all the powers down, so I get 3 log CA plus 5 log CD, distribute the negative log C4, minus log CB, minus, and the 2 can come down. Holy shit. So that's how that number 6 problem on the homework works. Your problem you got there is not as bad as that. Doesn't have as much going on. It's still not pretty at all. It's a good idea to start with the division to break it up. You don't have to. My way just kind of starts, what are all the positive terms? Stuff on the top. What are all the negative terms? Stuff on the bottom.
So you change the sign because of the negative.
Yeah, because it's minus this whole thing. So it's being minus all the parts of this thing, then the negative crosses through. All right. Crowd goes meh. Anything else from the homework stuff? Everybody got the homework stuff, hopefully? Anybody need the homework sheet?
Give me the same one from the homework class.
The second, what do you mean the second
You
one?
know, we have the little graph. You did.
Oh, the second graph.
Yeah, this one.
Well, that's what we got for that angle.
Eventually. Just kidding.
No, eventually it's fine. As long as that's before the, by the day of the test. So let me do one like that, because I don't want to do your homework for you. So if I had 1/3 to the x. Right? So what I always do, if there's a function I'm not sure what it looks like, I use these 5 numbers. It's got 0 in it, it's a combination of negatives and positives. That's what I start with, and then if it's not good enough, I add some more in there just to see what's going on. Alright, so, and then it's just a matter of actually doing the problem. If x is -2, this is 1/3 to the -2. What's the negative power do?
It makes it.
So now it's 3, and then I have to square it. 3 squared is 9. So now I get the point -2, 9 I can graph if I want to. So, and what's 1/3? Now x is -1 here. What's 1/3 to the -1? Well, that's just going to be 3, because the negative power makes it flip. And it's the first power stays the same. So it's 3. What's 1/3 to the 0? 1, of course. 1/3 to the first power. Oh, shit.
Oh, shit.
1/3 and 1/3 squared? No. 1/9. 1/3 times 1/3 is 1/9. Negative power makes it flip. Cool. But there's no negative anywhere. It's going to be just 1/3 times 1/3, 1/9. And now I can pick out of here points. I'm not going to pick that one just so my scale doesn't have to be that tall. Right?
So you just pick any numbers? For the
Yeah, you got to know the shape. I mean, can everybody draw in the air what e to the x or some a to the x, something like that looks like? Well, it's like this. Now, this one's interesting because the base is flipped. Notice how the negative powers come out big and the positive powers come out small. It's the opposite. So this is going to look like this. It just flips. 3 to the x would look like this. 1/3 to the x looks like this. That's why I want to give you this problem. And you'll start to see that when you start to plot these out. Where am I at? I want to go up to 3. So we got -1 goes to 3. 0 goes to 1. 1 goes to 1/3. 2 goes to 1/9. So you can see, oh, scheisse. Just let it go, Jeff. You'll be fine. Whee. There's the shape going on. Going the other way now. This is related to radioactive decay. You wait some time and it's get less and less radioactive. You guys heard of radioactive decay?
Yes.
That's why, for example, Chernobyl, when it had its trouble, right? They made horror movies about the shit, but it's going to take thousands of years before the radiation is to a level that allows for humans to live there. It just takes a long time for it to decay, for it to become not radioactive. So a normal exponential models population growth, right? You get some people, you give them some time, they're going to make more people.
Yeah.
Right? This is decay. This is like radioactive decay is normal, the one you normally think of. Okay, maybe.
For the x, are those always the numbers that you would?
These are the ones that I highly suggest people start with.
Okay.
Depending on what the function looks like, these might not be good enough. Maybe you got to put some fractional stuff in there, possibly.
Okay, but for the most part.
I start here, and then I see if that's good enough to get an idea what the shape is.
Okay.
Yeah. I like it. Now, depending on the function, why would this not be good to use if my function was the square root of x? Because square roots can't handle negatives, You see, so if it's that, I'm not going to use those, obviously, right? Yeah, okay, I like it. I like it. All right. Anything else from the homework stuff, or yeah? Oh, okay. Well, so with logarithms, it's basically this reversed, right? So with logarithms, you just have to be really smart about what you plug in. You can't use the -2 stuff. You got to think backwards for logarithms, because logarithms are inverse functions. They're the opposite. So if I had log base 4 of x, what's some smart stuff to plug in there? Would I plug a 2 in there? Maybe, but not really. But would I plug a 3 in there? What's log base 4 of 3? It's the power that 4 needs to become 3. I don't freaking know that. Shit, I don't think you that.
Powers of 4.
Okay, I like it. So a good place to start would be powers of 4. People miss the first one, though, and there's even more below it. But you can't plug a negative in there, because you can't raise 4 to a power and make it become negative. Yeah, 4 is a good idea. Log base 4 of 4 is 1. Log base 4 of 4 is the power 4 needs to become 4. 1.
So like, would you do like 16? Right?
Yeah, sure. 16. Log base 4 is 16. 2. Why would I not do 8? Because what do you raise 4 to make it 8? Nothing
You
pretty.
can.
You can. It's just not pretty.
Never mind.
So be careful. The points I'm picking are ones that I want to have be easy for me to graph. That doesn't mean the points in the middle don't exist. They just mean they're kind of ugly. It's not easy to graph by hand. Now somebody's missing something up here. A few things up here. A couple things at least. 0 is no good. What do I raise 4 to make 0? I can't.
1.
Yeah, 1. What's log base 4 of 1? What do I raise 4 to make it become 0? To make it become 1? 0.
0. Thanks.
And then there's something even below that. 1/4. What do I raise 4 to make it become 1/4? -1. But somebody pointed it out. It's multiples of 4, but not really multiples of 4. It's powers of 4. It's things that are based on 4. See how all of these are based on 4? That's the inputs I'm going to choose because it's based on 4. If I put a 3 there, I would use stuff like 9, 3, 1, 1/3. Cool. And now you got a bunch of points you can plot. Got the point 1/4 -1. 1/4 -1. It's about right there. 1 0. 4 1. 4 1. Freaking 16 too. Screw that.
Screw that.
And you got to realize, if exponentials look like this, and they have this asymptote here, and we talked about this before, the mirror image effect. This is going to be like this. Whee! It's going to have an asymptote here. It just takes that and flips it. It makes sense because they're opposite functions. So it's like a mirror image. You're opposite, right?
Opposite is my name.
Well, they're your reflection. It's the reverse of you in a lot of ways. Right?
It's gonna be weird.
I know it's weird. It's neat. Okay. So really, both of those are just being smart about what you plug in so you can make points, plot them, and connect them. That's really what that is. Just being smart about what you plug in so you can make good points. All right. So anything else from that homework before we get into some stats review stuff? Okay. Man, you guys have the weight of the semester on your brains, I think.
I'm ready for the summer.
Okay. Let me give you this first, and then I'll give you the practice final thing later. See if you guys, if this looks familiar. So we're officially kind of transitioning into review, but I'm going to start with the review stats stuff.
That's it all.
Say again?
That's it all.
Yeah, man. That's it. Now, is that all you can do with log? No, that's all we're going to talk about. That's all we got time to talk about.
This,
That's plenty.
trust me, it's a lot of work in this.
I know, right?
All right, so why don't we do this? You guys group up if you want to.
If I know what I'm doing.
Work on this, and then we'll do it together. If you gave me the calculator back, you might want to get it back. If you need it. Just to remind you guys, mean you should all know. What's the mean the other name for? Average. So everybody should know how to do the average. Median is what?
Middle.
It's the,
Middle number when what?
when you
All
add
numbers
them and
are
divide.
from the smallest to the
Good.
largest.
When in order. Otherwise, it wouldn't mean shit. I could just make anything the median I want. The median house price is $200 in Lloyd. No, you gotta sort that shit. Mode,
The most.
number occurs the most. Remember, there could be a tie, so it could be bimodal possibly, but if there's a winner, it's that one. Yeah. What else do I have up there? Range and mid-range? Did I put mid-range?
Yeah.
Yeah.
Mid-range. I forgot that one.
Range is the largest minus the smallest.
Good. High minus low.
And
And then mid-range is a little evil.
it's the same thing, but add it and then divide by 2.
All right, good. So I like that. It's the same thing, just different. The mid-range is the average of the range, the high and the low. That's why you add them, divide by 2, because that's how you get an average. High plus low, divide by 2 gives you the number that's in the middle of the highest and lowest. Okay, so you should be able to tackle that first one. And let's see if you guys remember the second and third one. Let's see. Hopeful.